So we just learned in the last video of how to go from exponential form to logarithmic form, and from logarithmic form to exponential form. But we kind of didn't really talk about what we can do with logarithms, right? We know that we can go from one form to another form, but what do logarithms actually do? And so we're going to talk about 4 basic rules or properties of logarithms. Okay, and the first one we're going to talk about is adding. And so in our exponent rules, way back to like 9th grade, you do it in 10th grade, you do it in 11th grade, they never leave, right? We keep reviewing them. But our exponent rules, let's say when we multiply two things with the same base, but different exponents, right? So x to the m times x to the n is really x to the m plus n, right? So when we think about exponent rules, especially when we multiply two things with the same base, we're adding the exponents. So you can think about, for logarithmic rules, right, when we're adding, we're really multiplying, right? So we're kind of doing the opposite. So I wrote this blanket kind of algebraic statement out down here. And I know when we see variables and letters and all these things, we get really confused. So I'm just going to walk us through it. This is just generally saying, if I have log base b of a plus log base b of c, that really just means it's log base b of a times c. Okay? And I know that's still confusing. So we're going to do an example. Okay? So the example we are going to do is, and I'm providing you with the example. So if you are like, where did she pull these numbers from? I'm pulling them from my head, right? I already wrote out an example. I want you to see how it's done. So don't be confused at where this came from. Okay, so if I have log base 2 of 8 plus log base 2 of 32, I want to figure out what that equals. And so we notice, right, that these have the same base in our generic example. And lucky for us in this example, these two logs also have the same base. Okay? So if we just want to use this general rule, we just need to figure out what 8 times 32 is. So this really just turns into log base 2 of 8 plus log base 2 of 32 equals log base 2 of 8 times 32, which we can just write as 256. Okay, so I'll leave this here for a second so you can think about it. Take 2 seconds. Okay, and then I'm just going to go back in and rewrite 256. So the answer to this example is just log base 2 of 256. But why does this work and where does this come from? So I'll go through that a little bit really quickly. If we have 2 to the third, that gives us 8. So thinking back to when we would rewrite in exponential form, we can rewrite this logarithm as 2 to the third equals 8. So we know that the exponent needs to be 3. Well, okay, if this is 2 to the third equals 8, to get 32, it needs to be 2 to the 5th. Okay, and then we can think about this as 2 to the 8th to give us 256. And lucky for us, we'll use a different color. This really just means 3 plus 5 equals 8. So that's how the rule works, because 8 equals 8. So if all of this stuff down here confused you, don't worry about that. I just wanted to kind of give you some background of where this rule came from. If you memorize this specific thing, and you do this one step, right? 8 times 32 to get 256, we're golden. This is right. If you are a little bit confused and want some background about where this all came from, this is the background, okay? So we just talked about adding logarithms, right? And we equated that to really multiplying the insides of the logarithm. And now we're going to talk about subtracting. So if you guessed that when you subtract logarithms, you really divide the insides, you're correct. So good job, pat yourself on the back. But I want to go back to our exponent rules really fast. So in 9th grade, 10th grade, 11th grade, we've covered these exponent rules, right? So if we have two things with the same base and they're being divided and they have different exponents, we subtract the exponents, right? So x to the m divided by x to the n gives me x to the m minus n. And you've done this, you know this, we've practiced this so many times. And this really relates to this, right? So when we divide in our exponent rules, we're really subtracting our exponents. And then in our logarithm rules, when we subtract, we're really dividing, okay? And so again, I wrote this really long purple statement that has a lot of variables in it, but we're gonna go through it and we're gonna talk about what this looks like as an example. So if I'm going to give you the example, again, I'm coming up with the example. This could be a problem I give you, and I want you to find the answer, right? So I don't expect you to come up with your own problem. This is something I give you, okay? That is a question we sometimes get. So if I have log base 2 of 32 minus log base 2 of 8, what will that give me? Okay, so we now know our handy dandy subtraction rule. So if I have log base 2 of 32 minus log base 2 of 8, I'm going to get log base 2 of 32 divided by 8, right? And we all know that 32 divided by 8 is 4. So this right here turns into a 4. So take a second, think about that before I erase it. Okay, so hopefully you've understood this far. If not, you can rewind, look at it again. So I'm just going to fill this in with a 4. That way we're all on the same page. And so if you get this, that is your answer. But why does that answer work? And so I'm going to go back through again in blue and purple, and I will just kind of tell you, or show you, I guess, why this works. So we know that 2 to what power gives me 32? 2 to the 5th power. So 2 to the 5 gives me 32. And 2 to the what power gives me 8? 2 to the 3rd power. Right? And then 2 to the what power gives me 4? 2 to the 2nd power, right? 2 squared gives me 4. And so we can think about this as, okay, well, 5 minus 3 gives me 2. And where is the 5 and that 3 coming from? It's coming from here, here, and there, right? So 5 minus 3 gives me 2. 2 equals 2. That's where that comes from. So again, if you understand this, right, and you're able to do this, amazing. If you need a little bit more background or you're curious, why does this work? How does this really relate to our exponent rules? All down here in this blue and this purple, okay? But as long as you get this, we're golden.